Hello, this is Marshall from Scree LLC, and I have something interesting I'd like to show off. Hoping I have the PCB or the FPC cables I need. Uh, well, I don't have any open, but I've been trying to figure out how to do single key PCBs for your thumbs and how to populate them. So this is my newest version of vertical toe beams, and I call them vertical because they're connecting via a vertically mounted FPC cable. So these are your standard FPC cables. They're 6P, 0.5 millimeter pitch, and they just plug into here. And then we've got this little daughter board. What this daughter board does is it has a single FPC cable that'll go to one of my XAIO flexes. It'll plug right into the toes or thumbs, and then from thumbs to here. And then this connects to up to 6 single key PCBs for your thumb cluster. It has 3 on the front, which are your evens, and then 3 on your bottom, which are odds. And then these are using dual-sided connectors, so it doesn't matter whether the blue, the top of the cable is the stiffener, that's the word I'm looking for. The stiffener of the cable is up or down. You just don't want to flip it. So you can plug in here, and then this one you can plug into the underside. As long as you don't flip it, it'll work fine. And then from here to here. The other cool thing about this is I broke out all, let's see, can we zoom in? Hey, look at that. We can zoom in and we'll set that up real nice. So do I got a pointer? No. Here, we'll use this for a pointer. So I've got data in, ground, voltage plus for your LEDs. I've got a data out, and then I've got columns 1 through 6, and then I've got a row connection option. So you can do row 1 or row 2. And what that lets you do is, if you decide not to use this, you can just populate that. These 3 little pads here are jumper pads. So if you want the toe or the single key PCBs to be pulling from this, it's either just this hole here or here. That's row 1, or that's source of row 1. Or you can use this pad here, which is called actual row 1. This is just an alternative source. So let's say I had, I don't know, maybe 12 thumb clusters, or 12 keys in my thumb cluster for some very strange reason. What I could do is I could plug this to here, and then daisy chain these columns, C to C's all the way over here, take this data out and bring it to data in here, jump over ground and voltage, not populate this, and then populate R1 right over here with a separate pin from here. And I have a couple extra pads, I think, that I could pull from. Like I could pull from one of these. These are your traditional rows, but if you wanted to pull from one of those, then you've got 2 sets of thumb clusters, or 2 sets of 6 single key PCBs on your thumb clusters. These would be running on whatever R or this row pin would be. And then these would be running on the secondary R set, because you would join the middle and the right pad, whereas in this one you would join the middle and the left pad. Theoretically, you can daisy chain these as much as you possibly want. You could, instead of using flexible PCBs, you could use this. And then just they daisy chain back, and then a single one goes to a microcontroller. That is opposed to my first generation vertical toe beams, which are these. Now these are a lot more complicated and more expensive to produce because each PCB is unique. So this is a bean 1, and it has to go to a bean 2. And this one has to go to a bean 3, and it has to go to a bean 4, and it has to go to a bean 5 or a bean 6. You can start at, say, bean 3 to 4 to 5, and you don't have to do bean 6, but it has to go in that sequential order, in whatever way you want to go, and it can only handle up to 6. There's absolutely no way to do more. The way this connects to the microcontroller is you use I think these were 8 or 10 pin FPC cable from here to here, 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 and then finally from here all the way up to the thumbs connection. The pinout on this and this match. These being smaller don't. But what happens here is like let's say column 6, which maybe this one is, or this one would be column 6 and this would be column 5, is carried here and here and here and here. And you can sort of see that on the traces where there's more traces here than here, and then less, and then even less. And that's those columns that are meant for over here, just daisy chaining on each key. Instead of doing all that, this system makes it a lot easier to produce, the vertical toe beam's newer version. I haven't figured out a better name. I'm calling this right now a landing pad, because these all land here and then they jump up to the main board, basically like a daughter board. So that's what I've been doing with these. The pick and place machine is working even better, and I've got it placing dual-sided PCBs. I've got to work on mounting them in my oven a little better, because right now I'm just sort of taking the PCB when it's populated and rising it up with some extra PCBs on the side. But it works out fantastic, and these soldered actually surprisingly well. Anywho, this is Marshall signing out. Hopefully some of the neat stuff going on at Scree LLC is interesting to y'all. Bye.